to the whiteboard. Whiteboard. You see whiteboard? Okay. I suppose that you receive one Word document is about the basic function, no? The basic function. So the basic function is the function that we study here in college algebra. But today we are doing transformation. So we have basic function. The collection is constant function, identity function, square function, cubic function, and so on, absolute value, blah, reciprocal, blah, blah. This is the basic function. This is the function in which we start the problem. We start. And we are doing transformation to get a family of the basic function, no? So basically, we have 4 kinds of transformation. 4. I want to discuss it one by one, theoretical, and after I bring example. And number 1, easy example, and number 2, complicated example. Okay, look. The first transformation is called vertical shift. Now, vertical shift happen or occur when you, for example, you have a function y equal f of x, and you introduce in here plus something, plus one number. Okay, I want to call a. For example, elementary example. Suppose the function y equal x squared, que es the parabola. I know that the graph of this look like that, parabola. After we see in this one now, clear, super clear. And I suppose I want to discuss or want to determine the graph of the x squared plus 2. When you add into the graph, transform it like a 2 unit up. So when a is positive number, the motion is up 2 units. Okay, this is vertical shift. Suppose que y equal x squared minus 3. When the a is negative, it's going down. In this case, 3 units, no? Because in my example, I put 3. This is clear, the idea or no? Okay, but I want to see clear now. And decimals. Okay, I prepared one decimals document, a script to illustrate this transformation. Basically, we have 4 transformations, and they are combination. Okay, let me switch into decimals. Share screen, switch into decimals. This is decimals now. Okay. Do you see decimals?
Yes.
Yes or no? Yes. Okay. Look, this is my quadratic function. It's a parabola, no? It's a parabola. Now I want to do transformation. For example, here, f of x is the function. Suppose here, in black color. So the new function is a black. Suppose I am doing a positive. Look at the motion. A negative. Look at the motion. Okay. So this the technical name of this transformation is vertical shift. When the a is positive, up. When the a is negative, down. Okay. Do you understand very well this or no? Some question? No? No question? Super. Okay, this is the first one. The second transformation is, okay, you see the board? Okay, the second transformation is horizontal shift. Horizontal shift. It's a little bit different because in the function notation, you are or subtracting one number inside the parentheses. Now, si you subtracting or addition inside the parentheses, es obvio que affect basically the x-axis, not the y-axis. Then the motion is horizontal. Look. Suppose again one more time, we have the parabola, the basic parabola, y equal x squared. This is just example, but this is valid for any function. And suppose I want to do the graph of the y equal x minus 2 squared, or y equal x plus 3 squared. It sounds a little bit weird, but it's a fact. When there's minus, the motion is to the right. I want to illustrate clear in this one now. Suppose this parabola, when you subtract into, is here. This point is 0. Now this point is 2. It's over 2. So you plug in here, 2 minus 2 is 0. 0 squared is 0. Okay, y is 0. And here it's completely opposite. It's to the left. To the left. So when the number inside the parentheses in the function notation, no, is negative, the motion is, well, the motion is always horizontal. But in what direction? You have two possibilities, right, left. When the number is negative, the motion is to the right. And for example, when the number is positive inside the parenthesis, the motion is to the left. So the parabola moving like that. Left, right. To understand much better and to see more clear, I want to switch into decimals. Decimals now. Okay. This one. So here. Okay. Okay. This was the previous example, no? But I want to change not A, I want to change B. Okay. Okay. Again, one more time, we have the basic. The basic, remember, was the red color. And now the transformation is the black color. In this case, they are perfect coincidence because A is 0, B is 0. But I want to change. Suppose B negative. And positive. Okay? FB. FB. When the B is negative, and in this case is because I suppose, okay, when the B is negative, is right. Something is weird. And when the B is positive, it's to the left. Okay? Suppose. Let me write here to understand much better. Okay, a new one. Suppose y equal x squared, pero paréntesis, es paréntesis, open paréntesis, x minus 2, for example. Square. Close the parenthesis, square. Look at that. Okay, in this case, forget about this. In this case, so the original, the basic is the red one. And when this minus, okay, the motion is to the right. However, say I change, suppose in another line, I put y equal, open parenthesis, x plus 3, no? X plus 3, que was the example that I put in the board, open, close the parenthesis, square, Here. Entonces, green color is the motion is to the left. Okay, look. Repetition again. This is my basic function without transformation. Record. We are doing the first transformation, que is subtracting. -2. Boom. The motion is to the right. How many units? 2 units. Look, I suppose that this is 5. 1, 2, 3. 1, 2, 3, 4, 5. This is 2. Now, another situation. Suppose that the number inside is plus. That is plus. Entonces es plus. The motion is to the left. How many units? 3 units. In this case is -1, -2, and -3. Okay, entonces keep in mind, vertical shift, horizontal shift. Let me summarize so far the information that we have in this moment, no? At this moment we have, okay, do you see the board or no? Yes or no?
Decimals.
Decimal, okay, thank you. Boom. Okay. So far we have shift. Shift is equivalent to say translation. O sea, no zoom in, no zoom out, no deformation, no compressing, no stretching, no. It's just the same shape, but a different position, different location. Entonces, when you adding outside the number, outside, you have a function. This is my original function. However, when you adding one number outside, basically, the thing that we are doing is, suppose that we have an arbitrary point x comma y. So when you are doing a transformation, this is x and y plus a. Okay, basically when you adding here, you adding, but on the y value. That is the reason that the motion is, when the a is positive, the motion is up, and when the a is negative, the motion is down. However, in the horizontal, it's completely different situation. You're adding or subtracting inside the parenthesis. And when you adding or subtracting, when you do an operation inside the parenthesis of the function notation, the geometric transformation is completely opposite to the operation. So you adding is subtraction. Let me show you. Suppose the point x comma y, when you transform it, you affect the x, but on the opposite operation. Okay, si es plus and minus, and the y stays the same. That means that when you adding inside the parentheses, the motion is to the left because x decreasing and y stays the same. And when you addition, o sea, es plus is left and negative is right. Okay, because it's negative, double negative become positive. Therefore, x plus something is the motion is to the right. Okay, this is the first two transformations. Let me study now the transformation 3 and transformation 4. But transformation 3 first. Transformation 3 is vertical again, but no translation, no shift. It's a stretch, compress, and reflection. Reflection. Compress, out, compress, and reflection. In this case, your multiplication, the function. This is my original function. Okay. But your multiplication, this by one number, right? Y equal, I call C f of x. A multiplication by C. C may be a 2, 3, 4, 5, or -2, -1, okay? C is multiplication, no addition, like the shift is addition. In this case, stretch, compress, or reflection is no, it's multiplication. It's a multiplier, it's a factor. Now, if you see que C is a number bigger than 1, for example, 2, 3, 4, 5, 100, is a vertical stretch. It's a vertical stretch, que es the first category. Stretch means que is enlarged. Suppose one image. Actually, when you are doing the graph of the function, it's an image. No? Suppose one image like that. You multiply this image times one factor, and this factor is greater than 1. Suppose 2. But you multiply only the y component. I suppose that the new image look like that. The same width, but enlarge the length, the height. Okay? This is something, image, and this is 2 image, and 3 image more. Now this is the idea. Stretch, vertical stretch, and representation like a point is x stays the same, but y no, y multiplied by c. C is a number, in this case greater than 1, I suppose que 2, 3, 4, 5. cy x. Let's see after in decimal the animation, and you understand much better. Suppose now que c is less than 1. Well, actually is c less than 1, pero en less than 1. C is less than 1. Suppose c less than 1. For example, 1/2, 1/3, 1/5. Entonces compress. Why compress? Because x stays the same, but c now is, suppose que es 1/2. Así es 1/2, entonces the y value is reduced, and my image will look like that. Okay, it's an image divided by 2. It's compress. Suppose now, specifically, que c is equal to -1. Well, in general, negative number, no? Pero si es -1, it's a perfect reflection. Because x stays the same, but the y changes the sign. Entonces now, if you multiply by -1, we have the same phase, pero in opposite direction. It's perfect reflection. Okay, this is minus image. Okay? Let me try to understand in Desmos, and now you see more clear. Look. Okay, switch into Desmos. Okay. Okay, there you go. Okay. Again, we have now, okay, put this in 0, no translation. Let me put on enable. This is my quadratic function again. Okay, super. Now I change the factor c, no? Okay, the factor c, I suppose is 1, but in this case, no. In this case, for example, I change c to, look at what happened. This is the important moment. Ooh, okay, this is vertical stretch. This is vertical stretch. And this is, okay, we come back to the original. When this one is the original. And when you affect by the factor less than 1, 0.7, 0.5, entonces it's compressed. You see? Compressed. Vertical compressed. Specifically, -1. Boom, look at that. It's reflection. Pero reflection with respect the x-axis. Okay? With respect. So the x-axis behave like a one mirror, and the parabola, in this case, is a function parabola. It's supposed to be parabola to explain this pero no always es parábola, es any function, is reflected. Okay, but in general, we have different situations, for example, sorry. Let me try to move this. Okay, look. Okay, remember, when the factor is greater than 1, vertical stretch. Ooh, super narrow parabola. Now, when the factor is less than 1, vertical compress. When the factor is negative, it's reflection. Si es negative 1, it's perfect reflection. But we have different combination, no? The combination is, in this case, for example, negative 2.5 or negative 3. So we have two situations. We have reflection, but you have also a stretch, vertical stretch. Well, suppose this case is negative 0.5 or negative 0.4. In this case, we have reflection because it's opposite sign, and we have compress. But when it's less than, when the absolute value is less than 1, is compress. When the absolute value is greater than 1, is stretch. And when there's negative, it is reflection. And pure reflection is when there's negative 1. Pure reflection. Pure reflection. It's exactly the same, the image. Entonces, let me condensing the information in the whiteboard. Try. Here. Okay, there you go. Look at this. This is the central idea. When the factor, I call C, is greater than 1, the transformation is vertical stretch. When the factor is less than 1, it's a compress. 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 And when the factor is exactly negative 1, it's reflection. And they are combinations. Suppose that in one problem, we have y equal minus 2x squared. Okay. This is my original parabola without transformation, y equal x squared. And I can see factor 2 is greater than 1 is stretch and negative 1 is reflection. So I suppose that my transformation look like that. It's a little bit narrow like that because it's vertical stretch, but we have negative, and negative means reflection. Okay? Do you understand this idea? This is a theoretical part, guys. Now I promise we see example. And little by little you understand. This is a process. Let me try the last transformation. Number 4. And number 4 is horizontal. Horizontal, exactly the same. Horizontal, stretch, compress, and reflection. But you introduce or you produce a horizontal, stretch, compress, or reflection when you multiply by one factor, I want to call this, but inside the parenthesis. Okay? Inside the parenthesis. Then we have, again, different 3 situations. Let me make a zoom. We have 3 situations similar to this. When the D is greater than 1, it's completely opposite, it's compressed. But what kind of compress? Horizontal compress. Why horizontal compress? Because you change X And now you multiply, no, you divide, because remember the operation inside the parenthesis is reflecting in the function completely opposite. Entonces, x over d, division, comma y. And si you are doing the division, suppose que d is greater than 1. Entonces, you divide by 2, you divide by 3, you divide by 4. Therefore, the x value is decreasing. Entonces, it's like a compress. Okay, suppose again the image, like that. When you, for example, multiply by 2 here, this is compressed. Look like that. Okay, this width is reducing by 2. If d is less than 1, so it's completely opposite, it's a stretch. It's a stretch because if d is less than 1, when you divide by, suppose you divide by 1/2, it's equivalent to say multiplication by 2. So suppose it's something like that. This is horizontal stretch. It's the same formula. And when the d is equal to -1, so when you put -1 inside the parenthesis, it's reflection. But reflection about, in this case was about x axis. In this case, about y axis. About y axis. Well, the parabola is no good example to illustrate this transformation because the parabola is like that. When you apply reflection about the y-axis, the parabola stays the same. Like reflecting rotation here, it stays the same. Entonces, pero I'm using another function. Suppose I'm using in the collection, in the library of the function, I'm using the square root function. This is the function y equal square root x. When you introduce -1 inside the parenthesis, look at what happens. You put here y equal square root -x. The function is reflecting about or with respect the y-axis. Right? This is this function y equal square root -x. Okay. This is maybe confusing, but we see immediately in Desmos with the animation. Let me switch it to Desmos. Okay. Okay. I want to no parabola anymore. No parabola. Parabola no. Because parabola is symmetric. The square root function. Look at that. The square root. Okay, you're familiar a little bit with the square root function because you see in the library of the function we studied in algebra, no? However, I want to do the family of this. In this case, let me switch in this to 1. Okay, let me change the color, black color. Okay, black color. There, in this case, there are perfect coincidence between red color, que is the origin, and the black color, que is the transform. Okay, now I change D. When I change D, for example, D greater than 1, look at the effect. This is a little bit confusing, I understand that. But see, you analyze one point to compare the position, you see in this case the curve is moving to the left. That is because we have horizontal compress. However, more clear now. Suppose again I come back to 1, no transformation. I put D less than 1, 0.8, 0.5. I suppose that you see clear now that we have horizontal compress. It's like somebody pull in the right direction. Horizontal compress. And what about -1? Look at what happened in -1. So you put D equal -1. Bang! Look, it's perfect reflection. It's reflection, but another kind of reflection. It's reflection about the y-axis. So the y-axis now behave like a mirror. Bang! And reflecting. But remember, the transformation is the black color, the original is the red color, no? It's completely different situation. And when you change the sign outside the parenthesis, is reflection about x, and you change the sign now inside the parenthesis. Therefore, the reflection is with respect to the y-axis. Okay? Okay. Okay, let's move on to the whiteboard because using this theoretical part, I want to discussing several examples, no? I bring some example easy, and after I see another example more complicated. Okay, let me erase the board. Okay, good. Okay, example 1, to understand the idea for the transformation. Okay, let me start for the elementary example. To do the graph using transformation of this function. F of x is equal a square root x plus 6 minus 5. Pero minus 5 outside the rack. Number 1 step is identification. What family of the function that you know in the library of the function of the Corel algebra belong this example? Entonces it's easy because they belong to the family of the square root function. Remember, this is the basic. This is the mother. And this is one member of the family. Because involve the square root, no? Entonces, the second step is understand how many transformations you can see here. Well. You're adding 6 and subtracting 5. But in what order is the correct analysis? Well, according to the order of operation. And the order of operation is you are doing inside, so you consider a square root behave like a parenthesis, you know? So in algebra, they are different grouping symbols. It's parenthesis, square bracket, absolute value bar, and radical is also considered a grouping symbol, no? So basically, in my mind, this function now, the transformation that I am doing is, look, is f, oh, no, you put a y, because it's different name, no? You put a y, y is equal f and x plus 6 minus 5. Okay? So you basically, you're adding 6 inside the parentheses and subtracting 5 outside the parentheses. So basically, the transformation is number 1 is a horizontal shift 6 units to the left. Okay? And we have vertical shift 5 units down because it's negative. Okay? So you are doing by hand. No, by hand, no. Let's do it using decimals. Okay, let me open a new folder of decimal. New. Let me save that. Open new. Open new. New and blank. Okay, super. You copy. All right, let me switch in. There you go. Beautiful. Let me call this example 1. Example 1. That's the name. I want to copy the original. The original is y equal square root of x. Square root of x. And the other line, for example, I copy the new one, que is y equal a square root x plus 6 inside the square root and outside minus 5. Let me try to understand this. Okay, look at that. I can see the original is a blue. The transformation is a green. We are doing 2 transformations. The first transformation is horizontal shift 6 unit to the left, minus 5 unit down, vertical shift. Any question? I condensing this. I'm ready to prepare the example 2. Do you understand? Everyone follow me? Complicated, easy, fantastic. We are the best. Okay, good. Understandable, guy, or confusing?
Yeah, it's easy.
Well, for you, okay? No, it's not easy always. A student make a mistake or a student don't understand. Okay. Let me complicate a little bit now your life. Okay, suppose example 2. Example 2. Come on, example 2. Okay, there you go. Example 2 now. Example 2 is f of x is equal minus x minus 5 squared plus 3. Okay, number 1 step is identify what function in the collection of the library we have in college belong this example. What do you think, guys? Come on, activate the microphone. In the collection of the function, what do you suppose que es?
It's a parabola.
It's a parabola. Very well. It's a parabola. Es y equal x squared. Parabola. O quadratic function. Either way you want to call it. Number 2. How many transformations you can see in this example? Okay. Be careful. How many? And one by one. In what direction is moving or reflection or I don't know. Or stretching or compressing or blah, 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 blah. Okay. What do you think? Transformation. How many transformations? 1, 2, 3, 4, 5. How many transformations?
3.
3. You are right, miss. You are right. Because we have, first of all, according to the order of operation, you are doing this part first, x minus 5. So we are doing this transformation, x minus 5. And this is what? Who help me?
Horizontal translation to the right.
Exactly. Horizontal shift to the right 5 units. Very well. Now, the next transformation, according to the order of operation, is minus here. And this minus, what does it mean? What this minus? What does it mean this minus?
Is that the reflection?
It's a reflection, but it's a reflection about the x or about the y axis. X or y? Because we have 2 kinds of reflection. No?
Is this on the x?
Exactly. Let me in this corner condensing the idea. When you are doing look reflection like that, minus f of x is an x-axis. However, when you have f and minus x inside the parenthesis, it's y. No, in this case, no y. It's this because it's a minus outside. Finally, plot 3. Finally, plus 3. The final plus 3 is, I have no idea. Help me, guy. Plus 3.
A vertical shift.
Vertical shift 3 unit. Very well. Vertical shift 3 unit. So basically, we have horizontal shift 5 units to the right because it's negative. The second transformation is reflection. Reflection about x-axis. I know it's about x-axis because the negative is outside. And finally, vertical shift 3 unit. So you're putting off the microphone. Okay, 1, 2, and 3. Hey. Microphone off. Eso. Okay, thank you. Let me go to Desmos to understand this transformation. Here. Okay. Let me try. I suppose you see Desmos now, right? Let me apply example 2. Example 2. An example 2 have the original function que you say que es de parábola, ¿no? O cuadrado function x squared. It's a parábola. But little by little, we are doing the transformation. Suppose y equal parenthesis x minus 5. Close the parenthesis and square. Do you see the transformation? Do you see the transformation? The transformation is, look, horizontal shift 5 unit to the right because it's mine. Okay, super. Now I put the negative outside. Negative outside, boom, reflection about the x-axis. And finally, plus 3. Plus 3 gets vertical shift 3 unit up. End the story. This is the final graph doing step by step with the transformation. Any question? Any question? Any question? Any question? All right. Okay. Moving on again to the whiteboard. Whiteboard. Okay, whiteboard. Okay, whiteboard. Okay, example 3 now. Now you help me. You help me. You help me. Example 3. Example number 3. Example number 3 is, look, is f of x is equal x minus 1 cubic power plus 7. Okay, remember the procedure. Step number 1 is try to identification what function inside the collection of the library that we have in college algebra belong this example. Okay, what is what?
Cubic.
What is the name? What is the name? Come on, man.
A cubic.
A cubic. Excellent. Now number 2, I want to identification how many transformation and what kind of transformation. In the function we have here. This is the first transformation because you apply like an order of operations. So this is the first transformation we should do. And finally this. So we have 2 transformations. No? The first transformation is, who help me? Come
A
on.
horizontal shift to the right.
Horizontal shift to the right. 1 unit. Horizontal shift to the right. Because it's something like that. Sorry, this is no f of x. I want to call an easy way y. It's a y equal, so this is f x minus 1 plus 7. It's a horizontal. The first transformation was horizontal shift 1 unit to the right because it's negative, no? And number 2 is vertical shift 7 unit up. Okay? Let's do it in this one. Okay. I suppose in this moment you see this one or no? Yes or no? Yes?
Yeah.
Okay, I want to call example 3. Okay, enter. Are you familiar with the manipulation for the decimal? Okay, you click in the plus sign, add items, create a folder, you put the name you want, example 3, and you start. And everything is condensing in the folder. Okay, entonces es cubic function. Cubic function is y equal, let me see, y equal, and the keyboard is easier. Any power different to 2 is this key. Ah, no, sorry, carajo. You put y equal, you put x power function 3. Boom. And this is my cubic function. Look like that. And my example is now y equal, open the parenthesis, x minus 1, close the parenthesis, power 3, boom. Look at that. Is horizontal shift 1 unit to the right. Now, minus 7. Minus 7 or plus 7? Plus 7. It's plus. Plus 7. I suppose that we have vertical shift. 7 unit up. Too much. Look, let me make it zoom to see. Wow. Do you see the green one? Is the original cubic function. And the next one is a family, member of the family of the cubic root, in which you are doing 2 transformations. The transformation number 1 was emotion, 1 unit to the right, and finally 7 unit up. Any question? No? Pretty easy. I want to complicate more this. This is the elementary example in which you identification super clear the transformation. But sometimes no. Sometimes we need to manipulate some algebra in order to see more clear the transformation. I bring 2 examples because it's tricky, confusing. I don't know why in the test always we have the tricky example, no? In this moment, you see the board or you see decimals?
Decimals.
Desmos.
Okay, board. Okay, this is example 4. Example 4 is confusing, very confusing. Example 4. Example 4 is f of x.
Mister, we still see Desmos.
Oh, sorry. Okay, it sometimes happens. I need to stop sharing and after select the screen I want. And now it's okay?
Yes, sir.
Super. Example 4 is confusing. Pay attention, que it's a little bit tricky. Square root 5 minus x. Remember, one first step is identification of what function in the collection of the library of the function in called algebra belong this example. Y es obvio que the answer is square root function, ¿no? Entonces you remember in the paper, square root function look like that, y equal square root x. Now the challenge is to see the transformation. What kind of transformation you believe that we have? Y en what direction? Entonces, you see, bueno, es inside the paréntesis phi. Pero phi is positive, ¿no? And also, it's confusing because we have minus x, no positive x. Si es positive x, everything is clear. Pero si es minus x, I suppose que we have reflection, ¿no? Pero what kind of reflection? Reflection about the y-axis. Okay, pero entonces you need to manipulate a little bit this expression in order to understand more clear this. So I propose you factorization inside the radical minus 1. Open parenthesis, and you have x minus 5. Okay, let me see if this expression is equivalent to this or no. I apply distributive property, look, minus 1 times x is minus x, and minus 1 times negative 5 positive 5. Oh, yes, it's equivalent. It's equivalent. Nice. However, you can see now more clear, in my opinion, I suppose, what kind of transformation we have. We have, okay, in the first place, we have this minus here. And this minus indicate reflection. Reflection about y-axis. And the reflection about the y, I suppose that this curve is like that. Okay? And also we have x minus 5. And x minus 5 inside the parenthesis is horizontal shift, no? It's a horizontal shift. Pero horizontal shift in what direction? In what direction? It's horizontal to the right, very well. Horizontal shift 5 units to the right. Okay, and the original expression is confusing. See, I don't understand very well. So basically, this is the reflection first, and 5 units to the right, 1, 2, 3, 4, 5. So my final answer, or my final curve, I suppose can look like that. Okay, this is exactly the same shape, but 5 units here. Okay, let me try to see in decimal, to see more clear,
Wait, mister, wouldn't it
Yes.
go to the left because you have that negative being applied? So shouldn't it be like plus 5 and it shouldn't go to the left?
No, it's right because this is negative. This is the confusing part, miss. Look, this is negative. See, we are doing this reflection first. We include this negative. And you focus in that part. And that part is negative, entonces it's reflection to the right. Negative to the right, remember, positive to the left, and the horizontal shift. Entonces, in this case, confusing. I don't understand very well. However, if you factor out negative 1, entonces I recommend when you see a square root something, entonces the sign here is not clear, you factorization negative 1. Now it's clear. Okay. Let me explain again one more time. Look at that, miss. Suppose that we have only this transformation. What is the name of this transformation? So I reflection. Okay, reflection. Suppose that we have now this transformation. Horizontal shift 5 units to the right because it's negative. Okay, and this together, que es this, It's both. In this order. Reflection first and horizontal shift 5 units to the right. Make sense for you or no? More clear now?
Yeah.
Yeah. Okay, super. And it's confusing. I understand. It's tricky, right? But okay, let me confirm it that we are doing well or no. And Desmos. Okay, I suppose you see Desmos now, right? Okay, press enter, example 4 plus folder, example 4. Okay. I know that this function belongs to the family of the function square root. Square root I can find in the keyboard of Desmos square root. Boom. This is my basic function. I need to transformation letter by letter. Okay. No, letter by letter. I copy, and after we analyze letter by letter. So suppose I copy the final answer. The final answer is y equal square root again. Is inside 5 minus x. 5 minus x. Boom. Okay. Exactly, we predict because look at that. Let me try in another color. Suppose y equal square root. Suppose square root minus x. Boom. In green color. It's just reflection. Okay. But suppose that I open the parenthesis here. Yeah, I put minus 5 here. It's equivalent, no? And this minus 5 represents the horizontal shift, pero 5 units to the right because it's negative, no? Okay, entonces you see que the green expression and the blue expression are equivalent. It's the same transformation. But in this case, in the green is easy or relatively easy to see. However, in the blue, no, it's complicated to see, to understand. Okay? More clear now? This is the tricky example. I understand. I bring another tricky example. Example 5 is tricky also. Okay. What's going on? Okay, sorry. I don't know why I closed the connection. Are you there?
Yes, sir.
Super. Sorry, this is my mistake. Okay. Okay. I want to come back to the whiteboard. Do you see whiteboard now or no?
No.
Switch to the whiteboard. Okay. Whiteboard. Do you see? No? No?
Yeah.
Yeah. Okay, this example, what number is example? 1, 2, 3, 4, 5, no? Example 5. Example 5. Example 5 is also tricky. Look at that. F of x is equal x squared minus, no plus, minus 4x plus 5. Okay, number one step is identification inside the library of the collection of the typical function we studied in college algebra. What is the basic function that belong this example 5. Y es obvio que es de cuadratic. Yeah, the parabola again, one more time. Yes or no?
Yes.
Entonces you say, bueno, why the parabola? Because I see linear here. No, it's the parabola. Okay? It's the most important part is the quadratic part. What is the transformation? It's not clear, the transformation. Why is not clear? Because you need to manipulate again algebraically this expression to understand more clearly the transformation. Okay, so in this case, one more time, we apply completely the square. Let me show you. X squared minus 4x plus, entonces I split 5 and 4 and 1. Because remember, the magic number que complete the square is 4 divided by 2 squared, no? 4 divided by 2 square 4 is a coincidence que 4. That is the reason que I split 5 using 4 and 1, no? Because I know very well that that part is a perfect square trinomial and the factorization is x minus 2 squared plus 1. Wow! And this expression is equivalent to this. It's exactly the same, but I modify algebraically. Now it's clear to see the transformation. What kind of transformation you can see, guys? Help me, please.
A horizontal shift and a vertical shift.
Exactly. You see in this order. Exactly, she said. Number 1, horizontal shift, 2 units. In what direction?
To the right.
To the right, because it's negative. And vertical shift, 1 unit, gets this one, plus 1. In what direction?
Up.
Super. Okay. Let's verification this idea in decimals, because I want to make sure. And always, we can use in decimal, guy, anytime. Okay. I go to decimals. I switch into decimal. Okay, I want to use decimals now. Click. Switch in decimals. You let me know if you see decimal now or no. You see?
Yes.
Let's create one new folder. Here's the example 5. Folder, example 5. And example 5, I copy my basic function. Okay, the basic function is y equal x squared. X squared. Okay, it's the famous parabola. Now I want to copy the original example is y equal x squared minus 4x plus 5. They see something like that. Wow. But I need to understand using transformation. Using transformation is y equal. So I open the parenthesis, no? Open the parenthesis. Inside the parenthesis, I have x minus 2, no? X minus 2. Remember? Close the parenthesis. Square. That transformation only was a vertical shift 2 units to the right. And remember we have plus 1, no? Okay, plus 1 is horizontal, sorry. The blue one, horizontal. Plus 1, okay, is the vertical shift. Wow, look at that. This expression, que is the red one, que is the original, is equivalent to the blue, pero in blue is more clear to see the transformation. In conclusion, we have horizontal shift 2 units to the right, and vertical shift 1 unit up. Super? No problema? Do you understand very well this or no? Let me try.
Yes, sir.
However, in the homework you see online, this is a typical problem that you see in the test on paper. However, in the test online, let me save this one. Example of transformation. Okay, this is the name that I want to put this. Okay, example of transformation. Okay, let me go to the board, whiteboard now, to put a typical example you can see, for example, in the homework online, here in test online. It's a little bit more, no super complicated, but it's different. It's the same idea, but different. Okay. Do you see the whiteboard now or no? Do you see or no?
No.
Okay. Okay. Whiteboard. Now? Now, yes?
Yes.
Okay. What is the typical example in the homework? Let me show you. Okay. One graph is given, no function. One graph is given, no function. One graph is given. Okay. This is my rectangular coordinate system. Okay. This is copy. Okay. And paste. No. Hello, what the hell? Copy. And paste. Paste is here. No. Paste. Ooh, what the hell is that? And the clipboard I have another thing. Okay, don't worry. Okay. This is the graph. Okay. And the graph is given. How? Let me show you. They call, for example, that function is y equal h of x. And no analytic. No. It's graphic. The graph is given. Look, let me show you. Like that. We have 1 point is -2, -4 here. Entonces we have a line, 0, is another point. And 4, -2, 4, -2 is another point. Basically, my graph consists in one segment line here and another segment line here. Okay, this point R. Let me continue with the blue color. This point is this point is -2, -4. This point is 0, the origin. And this point is the point 4, -2. Okay, thus I need, or I want to do the graph of the another function que is y, que is related, of course, with this graph, que es 2 h x -3. Wow, what the hell is that? Okay. Let me use another rectangular coordinate system. And another more, because we have two transformations, no? Okay, then the thing is, I need to identification. Okay. Perfect. Approximate. There you go. Okay. I need to identification. I need help for the identification. This is the graph case given. But what kind of transformation we have? What kind in this expression? What kind of transformation you can see? How many? 1, 2 transformation, 3 transformation. 2. All right, come on, help me. Do you follow me or no? All right, let me see your face. You follow me, guy? Campbell? Quesada? You are there, no? Robert? Natalie Navarro? Victoria Ferrer? Ismael? Alicia? How many transformations you can see? How many?
2.
Ooh, which one? What kind? And the order of the operation, no? Operation number 1, transformation number 1 is this. And the name is ta. Transformation number 2 is that. And the name is ta. Okay. What is that? What is the first transformation that you can see?
So, a stretch?
A stretch. Okay, miss, according to the order of operations, remember, you are doing the operation inside the parenthesis first. Yes or no?
Right.
Pendas.
So a horizontal shift to the right.
Exactly. Horizontal shift to the right, 3 units to the right. This is the first transformation that you should do. Because it's x minus 3 inside the parenthesis, no? And we're doing this transformation here. And finally, what is the second transformation that you can see? Multiplication by 2. And multiplication by 2, what's the name of this transformation when you multiply the function by 2? What's the name? What is the name?
Is that the stretch?
It's a stretch. But what kind of stretch? Horizontal stretch or vertical stretch?
Vertical.
Exactly. Vertical, because you multiply outside the parenthesis. Vertical stretch. And how do you know que es stretch and not compressed? How do you know?
It's bigger than 1.
Exactly. Because the factor involved in the problem is 2, que es bigger than 1. And no reflection. No reflection. No reflection, of course no, because this factor is positive. When the factor is negative, when you have reflection. Correct? Okay, so let's do in the first transformation. The first, number 1. Okay, any point on the graph, you move 3 units to the right. For example, this guy, que es 0,0, actually should be 3,0. This point now is 3,0. Because look, the first component gets 0, you increasing because it's to the right, it's plus 3 units. Like why this is increasing 3 units, minus 2 plus 1 is positive 1. Positive 1. And by the way, when you are doing the motion, horizontal shift, the y component stays the same, doesn't change. Entonces 1, -4. This point is 1, -4. Look, the x component is -2. -2 plus 3 is 1 positive. And -4 stays the same. So this segment now is this segment. Alpha. This segment now is this segment. Okay. And likewise, this is 7, no? Because 4 plus 3 is 7. No, 7 I suppose to here. 7. 7, negative 2. There you go. Here, negative 7. Okay, it's easy to understand because this is 7, comma, negative. Because you see it's the same shape, but you move 3 units to the right. Whoa. Okay. Now, the last transformation is multiplication by 2. 2 times h x minus 3. Now, you multiply by 2 the y component because it's vertical. And vertical is associated with the y. Now, these two multiply y, the y component, no x. How do you know when you multiply y or x? Depends. If the factor is inside, multiply x. If the factor is outside, multiply y. Entonces, at this point, stay the same. Professor, y stay the same si you multiply by 2. But you multiply by 2, the y component, and 0 times 2 is 0. And x stays the same because it's vertical stretch. This point is 1 comma negative 4. You multiply by 2, the y component is negative 8. Well, I suppose using my imagination that negative 7, negative 8, I suppose to here. This point is the point 1 comma negative 8. And the segment line now look like that. Okay, now the next guy is 7 comma negative 2. You multiply by 2, que es a factor 2, factor 2. The y component, no? Es negative 2, negative 4. Negative 4, 7, no? 7, negative 4, I suppose que here. And this point is the point 7, que 7 stays the same, comma, negative. Boom. Okay? Super. Any question, guys? Do you understand graphically? This is typical in the homework online. In the test online, you can see this kind of problem. Okay, one graph is given, and you need to transform. Okay? I have another example. If you have no question, we continue moving to the next question. Any question? No? Do you understand very well? Remember, guys, when you are doing the homework, don't hesitate to ask me any question. In the homework, you can. It's totally legal. Can you ask me? The perfect way that some students apply is you take a picture and so you open Alex, no? So I am stuck in one question. So you take a picture. You take a picture of the question you send me. In 5 minutes, I solve for you. I take a picture again. I send back to you. Okay? So this is a learning process. Of course, either way, you can use in tutor. But I am available for you anytime. Anytime because the communication is not instantaneously, but by email, no? Entonces I open the email frequently. When I see, question, I try to solve in one piece of paper in 5 seconds, take a picture, they send back. Okay? Okay. One more example. Let me erase everything. We are doing now another problem similar. Okay, contain again 3 graphics. Okay. Let me put a graphic. Okay. 1. 2. And Y3, the same idea because what we have the original. And we have two transformations. No? Okay. Super. Good. Very good. Okay. The middle is a little bit smaller. Good. Perfect. This is the graph. Okay. So one information is given. One graph is given. Okay. And the graph is given is the function y equal h of x. And the graph look like that. Look, we have 3 points again. 0, 0, negative 4, 0 here, and negative 2, negative 4. Negative 2, negative 4 here. Negative 2, negative 4. And the function is formed by segment line like that. Okay? And we need to do that transformation. Look, y equal minus h x plus 2. How many transformations you can see? How many? How many? How many?
2.
2. Number 1, number 2. And what is the name of this transformation? According to the order of operation.
A horizontal shift to the
A
left.
horizontal shift, very well. And what direction means?
To the left.
To the left. How do you know it's to the left? What is the clue that give me information that's to the left?
Because it's plus 2. And when there's
Exactly.
a plus, you go to the left.
Exactly. To the left because it's plus 2. And what is the last transformation? What is
reflection?
The reflection?
Across the x-axis.
Exactly. Reflection about x-axis. Because remember, what is a negative? So we have two kinds of reflection. When you have, for example, h of x, we have this reflection and we have this reflection. But in our example, it's this reflection because it's a minus outside. This is minus outside is reflection about the y axis. Okay, so we are doing step by step. The first step is y equal h x plus 2. And x plus 2, any point, of course, I take like a reference, the 3 endpoint, no? However, the entire curve can look like a B is moving 2 units to the left, no? Entonces this point actually is 0, 0 would be now, o sea, es, bueno, okay. The motion is horizontal shift. Therefore, when it's horizontal shift, the only component of the point can affect is x, and y stays the same. And this is left. Yes, left is subtraction. So this 0 actually is not 0 anymore. It's negative 2. At this point is transformed at the point negative 2, 0. Do you understand this? Because the x component is subtracting 2 and the y component, no, stay the same. And here is negative 6. Negative 6 because it's negative 4 minus 2, no? At this point now is minus 6, 0. And this point is minus 4, no? Minus 4, minus 4. It's a coincidence, no? Minus 4 here. This point is a point minus 4, minus 4. Okay, and this is my function after the first transformation. Everyone follow me? Sorry. This is the triangle, but it's, let me try to do my best. Okay. Ah, no, see, I have a rule. Carajo. I have a rule. I have a rule. Okay, this is good. No, not totally good. Here. Okay. We're connecting segment line, this point. The rule is heavy. Okay. This is the point 4, -4. And here. 1. Good. Much better. Okay. So this was, let me summarize, a horizontal shift to unit to the left. I move this B to the left to unit. Boom. Now, what's the next? Reflection. And reflection is super easy because you change the sign of the Y. Any Y, you change the sign. But a coincidence, this point and this point, the component Y is 0. Entonces 0, when you change the sign, it's impossible because 0 have no sign. 0, 0. Entonces this point, by coincidence, stay the same. Entonces the same. Okay. Es -6,0 and -2,0. This stays the same after the reflection. But this change, wow. Because this is -4, but you change the sign of the Y, no? Entonces -4, +4. -4, +4 here. This point is -4 and +4. This segment and this segment. Okay. Any question, guys? Do you understand transformation? Okay, I promise in the review packet we continue working with the transformation. No? But now it's enough. Okay. In the 12 minutes that we have, I want to introduce one application of the transformation. So in what part we use in transformation? Well, we use in transformation to identification, and this is extremely important. When the functions are so classification according to the symmetry, that you investigate symmetry of functions. That's very useful. When you are doing the graph of the complicated function in the test 3, in the test 4, we are doing the graph of the complicated function. It's good to investigate the symmetry. Then we have two kinds of symmetry. The first one is called even function. And what is the even function? Well, the even function is a function that when you are doing reflection, and you are doing always reflection about the y-axis. So you replace x for -x. And in this special function, even when you are doing this idea, the function, wow, amazing, stay the same. And this is even. And when it's even, it's because the function is symmetric. This is symmetry, no? With respect the y-axis. Let me show you. For example, to understand this. Suppose the function is given in the test. Well, suppose the famous parabola. You know, the graph of the parabola look like that. This is a classical example, que es a function que es symmetric with respect to y. That distance is equal to that distance. Symmetric. My sketch is not good, pero es symmetric. perfect symmetry. Entonces, to prove algebraically que this is even function, in the function notation, you replace x for negative x. Entonces es negative x squared. Well, this is like a minus 1. Entonces negative 1 squared and x squared, no? So you raise to the second power both. But negative 1 squared positive 1. So you compare this answer and the original. Shoot, is the same. And when this situation happens, it's even. And when the function is even, it's symmetric. We respect the y-axis. Okay? Symmetry. Entonces, what is good? And when you are doing the graph of the one function and you prove que es even, so you are doing, for example, only plot the positive value only and compute the y value, because I know very well que negative x, que is symmetric with this, is exactly the same one. Suppose in one hypothetical example, you find the point 5,4. I know que negative 5 is the same. It's even function. Okay? This is even. Let me see another example, more complicated of even. Suppose x to the 4th power, x to the 2nd power, plus 2 plus absolute value x. Proof que this function is even or not. So I write function notation. I change x for negative x, okay, in other words, we are doing reflection with respect or about y-axis. And you know, when the exponent is even, stay the same. It's obvious, right? 2 stay the same. The actual value of negative number is positive number. And we compare this and this. It's exactly the same. They are twin brothers. Therefore, this function is also even. And the graph of this function is symmetric with respect to the y-axis. Everyone follow me, guys? Okay, in the test number 2, we have one question in which you need to prove that the function is even or not even, odd or neither. Okay, I want to explain now odd and neither. So neither nor even, so even nor odd. Let me explain odd function. Odd function is similar, but it's another kind of symmetry. Odd function. What definition of? When you are doing the same reflection. When you are doing the same reflection, magically happen that the function is not the same, but it's totally opposite side. In other words, the reflection about the y-axis, que es this, is identical to the reflection about the x-axis. What is the super frequently or common example of this function? Suppose the function cubic, y equal x cubic, que this function look like that. Okay? Let's do a reflection, for example, about the y-axis. It's like that. This is the reflection about the y. And what is the reflection about the x? I know, okay, it's something like that. Look, that part change the sign, and that part change the sign. They are perfect coincidence in between two reflections. Okay. This is geometric, okay. Maybe I understand or I don't understand. However, algebraically, it's easy. Suppose cubic function. You express in function notation, you replace x for negative x, because I make a reflection, You separate negative 1 cubic and x cubic. And negative 1 cubic, negative 1, negative x. When you compare this and this, it's not the same, no twin brother, therefore it's not even. But it's completely opposite sign. Yes, it's completely opposite sign, therefore it's odd function. And we have one special symmetry, it's called symmetry with respect to the origin. Because look, so you select one value of the x here, positive, you get one value of the y. When you select exactly the same negative value, opposite sign is negative y. This is the idea of the odd function. Okay, entonces even, let me summarize the idea. Even is, the symmetry is something like that. Odd is something like that. Even. Odd. Suppose a function like that. 1, 1. When you select arbitrary value of x, and you get one value of the y. When you select exactly the same minus x, you obtain exactly the same value of the y. This is even. Odd, no. Odd is when you select one arbitrary value of the x, you get one value of the y. When you select the opposite sign, minus x, you get the opposite sign of y. It's the same value, minus y. This is, suppose que es 5, and this is negative 5. Negative 5. So it's exactly the same absolute value, but it's opposite sign. In this case, no. In this case, it's exactly the same value. Suppose it's 5 both. Okay? But we take advantage this. And even and odd functions are special, super sophisticated function. But otherwise, the other function that do not satisfy this condition is called neither. Neither is ordinary. It's not special. You prove in example que I bring in the review package several functions. Proof algebraically. Si es odd, even, or neither. Okay, suppose 3 examples. 1, 2, 3. Suppose y equal x to the 4th power plus x to the 2nd power. Suppose y equal 2x to the 2nd power, to the second, no, to the cubic power, divided by x to the 2nd power plus 1. Suppose this y equal x cubic plus x. One more example. For example. And number 4, y equal x to the 2nd power plus x plus 5. Now you prove algebraically, see these functions are even, odd, or neither. What do you think about the first one? Using your common sense and intuition. What do you think about the first example? It's even, it's odd, or neither? Help me. Answer me. No idea. Totally lost. You don't understand very well even, odd, or neither. What should I do? You replace x for negative x. When exponent is even, it's positive. Doesn't change. And this expression is identical to this expression. Therefore, the conclusion is this is even function. Do you understand this or no? Come on, guy. Answer me. Are you tired? No? I suppose, no? Too much for one day. Come on. Answer me. Come on, Campbell. Are you awake? Tico, Quesada, Robert, Natalie, Victoria, Ismael.
We're here, mister.
Okay, but are you tired? Too much information one day. This is intense, I know. It's a mini term. It's in 8 weeks. I need to explain color algebra. Pero okay, you are here. Okay. What time it is? This is the time is over. Okay, we continue doing this in the next class, okay? Okay. Remember the homework. Start practicing homework and any question